For making the lab2 predicting the motion, I used as a falling object a paper ball. I have moved the video into the tracker, obtaining an experimental model. Using a frame rate of 25 per second and a frame time of 0.04 seconds, I selected 17 frames for obtaining the best results. I chose the coordinate system X and Y axis, and I made also the calibration. From the tracker, I selected the initial data. Based on the central mass, the tracker analyzed the falling object and put the results into a table, drawing the experimental diagram. Using the Python program for a computation model, I set up the initial data. Based on Newton's second law and considering only the weight of the object, without any action from surrounding, I established only the gravity model. I built a new model taking into consideration the surrounding action as a drag force. Making few tries, I picked up the more appropriate value of the constant B from the drag force formula using the final data of the experiment. With the above found constant B of drag force, I obtained the drag force model. For showing the direction of the forces, I inserted in Python program arrows as vectors based on the calculated arrow scale. Bringing together the results of the experiment and both computer models into Google spreadsheet, I was able to analyze the motion of the falling object. Even if I fit the constant B of the drag force in order to obtain almost the same results of the experiment, there are discrepancies between experimental and computation model. This can be explained by the improper video capture of the falling object and by imprecise establishment of the mass center. As conclusion, I can predict the motion of the falling paper ball by using the computational models.